Hi guys, Miss Scott here, and today we're going to talk about the 5.6 notes in geometry. So before we get into that, here is your bad joke of the day. What did Mario say when he broke up with Peach? It's not you, it's me, Mario. Alright, so here we go. Kind of a longer essential question for today, so feel free to pause the video, jot that down. We actually have two essential questions. The first one is given two congruent sides in two triangles. How do you know in which triangle the third side is longer? And how do you know in which triangle the angle between the two sides is larger? Okay, so we're going to be making some comparisons with triangles. All right, so in this first couple of examples, those are going to help us come up with the relationship. So you can probably just see by looking at this which side is longer. So we've got side AB right here, and we've got side CD right here. And just by kind of eyeballing these two, we can see that AB is the longer side. Okay, and then that actually leads us to our first theorem. If two sides of a triangle are congruent to two sides of another triangle, so notice this side and this side are congruent to these two sides here, and the included angle of the first is larger, so you can see that this angle 50 degrees is larger than 40 degrees, then the third side of the first triangle is longer. So we could see that this side AB was longer than this side CD. Okay, that's called the hinge theorem. You can think of that angle, these angles in between, as like the hinges. So if the hinge is more open, the side across from it is going to be larger. All right. Okay, and then let's look at a second example to get the converse. Okay, so which angle is larger, angle E or angle F? Okay, and you can probably again see just by kind of eyeballing this that F is the larger angle. So if you have two sides of a triangle are congruent to two sides of another triangle, and the third side of the first is longer, so you can see that this 6 centimeters is longer than this 5 centimeters, but these two sides are congruent to these two sides. Then the included angle of the first triangle is larger than the included angle of the second. So since this 6 centimeters was bigger than this 5 centimeters, we knew that angle F had to be the bigger angle. All right, so that's the converse of the hinge theorem. And I think of this as if you have a hinge that's, the hinge is like opening a bigger separation, then that angle has to be bigger. All right, so let's use that on some examples here. The first thing we're going to do is just figure out if these are, what to put in the blank. Is this going to be less than, greater than, or equal to? All right, so first of all, we have A, B, and D, E. So if we compare this side, side AB, with this side, side DE, I always like to put the angle that they're across from above it, and then that helps me put some numbers with this. So across from side AB, we have 105 degrees. Across from side DE, we have 110. And we can see that 105 is less than 110 degrees. All right, so if you look above, if you're given two angles and you're trying to see what side is bigger, that's this theorem here. Okay, so we are using the hinge theorem. All right, so if it gives you angles and you're comparing sides, you're using the hinge theorem. All right, and in example 2, now we're looking at some angles. So we have the measure of angle 1. So we're comparing this angle here to the measure of angle 2. So across from angle 1, we have 7, and across from angle 2, we have 8. And we can see that 7 is less than 8, so angle 1 has to be less than angle 2. So if you're given sides, and then you're comparing angles, that's the converse of the hinge theorem. So we're using the converse of the hinge theorem. Oops. All right. So let's look at 2 more examples where the triangles are connected. It's a little bit harder to see. So we are comparing again angle 1 to angle 2, and they're not equal, so let's put a double arc on angle 1. So angle 1 is across from 8, angle 2 is across from 7. And we can see that 8 is greater than 7, so angle 1 has to be greater than angle 2. Again, if you're comparing two angles, that's the converse of the hinge theorem. All right, and lastly, we have this 28 degrees here and this 31 degrees here. So we can see that side TG is across from 31 degrees, so I'm going to put that above here. And TE is across from 28. We can see that 31 is greater than 28. And if you're comparing two sides, given the angles, we're using the hinge theorem. All right, let's move along to a couple more examples here. Right. So your next example is using the same idea, but this student here made a mistake. So what they're saying is that by the hinge theorem, this side AB has to be greater than this side DC. And we can't actually say that any comparison with those because this angle, 47 degrees, is not across from AB. And this angle of 35 degrees is not across from CD. They're actually adjacent. So they can't really say anything about these two sides because segment AB and DC are not the sides across from the given angles. So if that's not the case, you can't really say anything about the two sides. All right. So, sorry, student, that is not true. Okay, another example here. So we're going to use this picture here to set up an inequality and then actually solve it. So use the hinge theorem or its converse and the properties of triangles to write and solve an inequality to describe a restriction on the value of x. So what I notice is that we have this 30 degrees here is across from this 3x plus 2. And this 38 degrees is across from 12x minus 7. So let's actually make an inequality with those. I know that 38 degrees is greater than 30 degrees. Hopefully we agree with that. So using the hinge theorem, we would say the side across from 38 degrees, this 12x minus 7, has to be greater than the side across from the 30 degrees, which is 3x plus 2. All right, and then we can solve this just like we would any equation. So we can start by subtracting 3x from both sides of the inequality. So these cancel. We end up with 9x minus 7 is greater than 2. So we can go ahead and add 7 to both sides. These cancel. And we end up with 9x is greater than 9. So if we divide both sides by 9, we get x is greater than 1. So we know that in this case, the x value would just have to be something larger than 1. Okay, and now let's look at one story problem involving the hinge theorem. You and a friend are going shopping. You leave school and drive 10 miles due west on 26th Street. Okay, so you are at school, and then you go 10 miles west on 26th Street. So this is your route right here. That's where you're going. And then you drive 7 miles northwest on Raspberry Street to the grocery store. So then you end up, this is where you are. I'm going to put you so we know who we're talking about. And then your friend leaves school, and they actually go east on 26th Street, also 10 miles, so you go the same distance. But then he drives 7 miles southeast on Cascade Street and ends up at the movie store. So this is your friend over here. And each person has driven 17 miles. True. You both started going 10 miles on 26th Street and then 7 miles. Each person has driven 17 miles. Use the map below with its additional information to determine which of you is farthest from your school. All right, well, if you notice here, we've got a couple of angles that are given in this picture. So this 100 degrees is across from your distance, so your distance from school is here. And your friend made a 120 degree angle. So that one is larger. I'm going to use a double arc. So this angle is smaller than this larger angle. Well, what that means is using the hinge theorem, your friend has to be further because that angle across from his distance, which is 120 degrees, is greater than your angle that you created. So it's greater than the 100 degree turn that you took. So you would definitely be less distance than your friend. All right, and that is using the hinge theorem. So if we're using a theorem, we should probably say what theorem we are using. All right, so thank you guys for tuning into those notes. Please feel free to like the video, subscribe to my channel if you haven't yet, and we will see you guys next time.